Today we're focusing on 2016 exam type 2 question, particles in motion, and we're given the velocity equation and we're asked lots of questions. It should be noted that because the particle is moving along the x-axis, it's probably worth writing at the top of your page the relationship between position, velocity, and acceleration. It's going to save you in the end if you forget to write that down further on into the problem. So they give us velocity and they give us a position. You could call it the initial position, but it's at time 4, so it's not quite initial, but time 4, the position is at x equals 2. On to part A. At time 4, the particle speeding up or slowing down? Well, we learned in class speeding up means a of t and v of t share signs. So that's the question that it's asking us to determine. Do a of t and v of t share signs, specifically at time 4? So we need to evaluate both v of 4 and a of 4. And a of 4 we should recognize is the derivative at 4. Because this is a calculator active question, I strongly encourage you to use your calculator to evaluate functions. Because there's trig involved, I encourage you to make sure your calculator is in radian mode. So first, check that you're in radian mode. Second, because you're probably going to evaluate the function more than once, I would put the function into y1. So 1 plus 2 sine of x squared over 2. This is the velocity function. From the home screen, if I want to evaluate that function, I can press vars, scroll right to yvars, and select function. Evaluate y1 at time 4. Okay, that's not the only way to do it, but that's one way of doing it. 2.978. So v of 4 is approximately 2.978. Another way you could evaluate it, so you know, is if we look at the graph, and that's a terrible zoom. Let's do zoom 6. If we look at the graph, we get what the particle is doing relative to x around time 4. If we press our trace button, trace, and enter in 4, it will tell us the location is at 2.978. So that's another way to find that position. V prime of 4, there's lots of ways to do that. Graphically, the easiest way would be to press second trace and then select dy dx. That's going to be finding the slope, and then you type in the time 4. dy dx at time 4 is negative 1.16. Other ways of doing it with a calculator, if you don't want to do it graphically, you can do math 8 to pull up the derivative. So evaluate the derivative of y1 at time 4. So that's another way to do it, and it's from your home screen. It actually tends to be slightly more accurate from the home screen. But here we're not caring about accuracy, we're just caring about whether or not the answer is positive or negative. And this answer is clearly positive, and this answer is clearly negative, because they do not share signs. V of 4 and a of 4 do not share signs. Therefore, the particle is slowing down. Okay? If you have no concept how to tackle any of these position problems, just start evaluating derivatives, finding derivatives, doing stuff like that. It'll get you points some of the time. Now in this one, it's worth 2 points, conclusion with a reason. So taking the derivative would not be enough. But our conclusion is slowing down. I stated the reason is do not share signs, but it is important that you show that you actually evaluated the signs of these functions. Okay, it's not enough to just say they don't share signs. You have to prove that they don't share signs. Okay, so recall that one was worth 2 points. On to part B. Find the time when the particle changes directions. The particle is going one way when velocity is positive, and the other way if velocity is negative. So changing directions would be, where does v of t change signs? That's what they're looking for. So in order to determine where v of t changes signs, and they're only curious about the interval 0 to 3, we have to find where does v of t equal 0. Okay? And if we look at our graph that we have, we can see that it changes signs lots of times. V of t goes from negative to positive, or positive, negative, blah, blah, blah. But between 0 and 3, there's only one time that it changes signs, and we want to know where that time is. So we're going to ask the calculator to tell us what the 0 of the function is between 0 and 3. So if we press second trace, we can call upon the function 0 to find the 0 of the function. And they're going to ask for a left bound, a right bound, and a guess. Well, my left bound is 0, and my right bound is 3, and it looks like a guess of around 2.5. Okay? If it crosses more than once, you'll have to have a smaller window, but in this case, there's only one window, and that's at 2.707. So, at t is approximately 2.707. Okay. V of t changes signs, or more specifically, let's be specific because that's always better, changes signs positive to negative at that time. Therefore, particle changes directions. This part is worth 2 points. 1 point if you found the time where the v of t equals 0, and then 1 point if you're able to justify basically the remainder of the information. Changes directions when velocity changes signs. So remember, a positive velocity means the particle is moving to the right, and a negative velocity would mean the particle is moving to the left. In this case.
If you're trying to attract someone's attention, this will do the trick. Wow, that's cool, man.
Find the position at time 0. So again, I'm going to just put this down there because this is the overarching theme of this problem. Find the position at time 0. So they're asking us in part C to find the position at 0. Okay. The position at 0 is, we have to look at where it started and what it accumulated heading towards 0. So the only time they give us information is at time 4. So we know the position at time 4. And if I integrate from 4 to 0, of the rate of change of position, this would tell me what I am accumulating. Or since we're going backwards through time, you could kind of think about it as what I am losing in position. Now, x prime of 0 is the same thing as, x prime of t is the same thing as v of t. And they give me the v of t equation. So I have this piece of information, and I have the equation for v of t. So I have everything I need to simplify the right-hand side of my equation. X of 4 is 2, and that integral, well, it's calculator active, so I don't want to do it by hand, and even if I did have to do it by hand, it would be probably too difficult to do with your AB knowledge. I think you'd have to move into the world of BC, and even looking at it, I'm curious if I could do it in BC calculus. So we want to integrate, so we press Math 9 to integrate. we're going from 4 to 0, and I know that feels a little weird having the bigger number on bottom, but we're going backwards in time. Our velocity function we had stored under y1, so if you press alpha trace, that pulls up y1. And we're integrating with respect to the variable. I've been using an x, but just remember an x is the same thing as a t. Okay. That value is negative 5.815. Right away, since I'm using truncated decimals, it becomes an approximately. Negative 5.815 plus 2. The position at time 0 is approximately negative 3.815. This is worth 3 points. 1 point if you knew you were supposed to integrate the velocity function. 1 point if you knew you were supposed to use the initial condition. And then 1 point if you arrived at the final position. Or the position at time 0, I should say. All right, on to part D, find the total distance. So displacement and distance are two different questions, and oftentimes they ask one of the two questions. They look very similar. Displacement would be the integral from A to B of velocity, and distance is the integral A to B of the absolute value of velocity. Those are the two go-to formulas for total distance or total displacement. Okay. Total distance will always, 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 always be a positive value or 0. You cannot have negative distance. It is not possible to stand negative 3 feet away from a person. So if you ever arrive at a negative answer for distance, you did something wrong and you should panic. No, you shouldn't panic. You should just back up and try again. Okay, so we want to do this from time 0 to 3. So our initial time is 0, our final time is 3. The absolute value of v of t, again, it's not a very pretty one to do by hand, but it is a calculator active question, so we can turn to our calculators and have the calculators do it for us. Math 9 to pull up the integral, 0 to 3. And if I want to access the absolute value command, you can access that by pressing math and scrolling right to number, and you get the absolute value command. Okay. Now the newer calculators show it as absolute value bars, older ones just say ABS, but inside that you put the function, which we've stored under y1. So again, calling on that y1. Better get a non-negative answer. It thinks a while longer because the absolute value makes it harder for the calculator, but approximately 5.301. And I forgot to write down the key for how the grading is, but I imagine the grading comes from having the integrand correct and having the answer correct. That's my speculation based off of experience. Something to that effect.
Survey says, like and subscribe.